Have you ever wondered what happens to the Teflon on your frying pan after it flakes off and disappears? Or the waterproof coating on your jacket? Or the non-stick films used in industries, machinery, and high-tech electronics? The truth is uncomfortable. They don't disappear. They don't break down. They don't dissolve. In fact, they survive almost forever. These materials belong to a notorious family known as PFAS, per, and polyfluoroalkyl substances. Scientists call them forever chemicals because nature simply has no idea how to destroy them. But in 2025, everything changed. For the first time in human history, scientists have discovered a clean, low-energy method to break down Teflon and turn it into useful materials, a breakthrough many believed was impossible. And the story behind this discovery is stranger, deeper, and more eye-opening than you think. The dark secret of Teflon and PFAS. Ever since Teflon was accidentally discovered in 1938, humanity has used it everywhere. Cookware, medical devices, aerospace machines, microchips, firefighting foam, cosmetics, car engines, even the cables inside rockets. Why? Because Teflon doesn't react with anything. Almost nothing in the universe can break its carbon-fluorine bonds. These bonds are among the strongest in all of organic chemistry. Stronger than steel. Stronger than diamonds. Stronger than many metals under heat. That's why PFAS accumulate. In oceans, in soil, in drinking water, and even in human blood. Yes, recent studies show 99% of people tested globally have PFAS traces in their bodies. And for decades, scientists tried to break Teflon down with heat, chemicals, supercritical fluids, even plasma beams. Every method failed because the energy required was too high or too polluted. PFAS were truly unbreakable. The impossible discovery. Then, in a quiet UK laboratory, something unexpected happened. A team from Newcastle University and the University of Birmingham discovered a method that shocked chemists around the world. A way to recycle Teflon using a simple, clean, solvent-free process. The secret? A technique called mechanochemistry, using mechanical force instead of heat or solvents to break chemical bonds. Imagine grinding Teflon in a special reactor with certain reactive minerals. Instead of melting or burning, the crushing pressure snaps fluorine atoms away from the carbon chain. This was believed to be impossible. But the reaction worked. The long Teflon polymer chains collapsed, and the fluorine atoms, the entire reason PFAS are so dangerous, were captured and converted into useful fluorine salts. These salts are incredibly valuable. They are used to make advanced batteries, solar panels, pharmaceuticals like anti-cancer and antiviral drugs, and high-performance electronics. In other words, we can take a toxic, forever chemical and turn it into a building block for futuristic technologies. A perfect chemical circle. What makes this discovery so unique? This isn't just ordinary recycling. It offers 5 world-changing advantages. Firstly, it works at room temperature. No huge furnaces. No massive energy waste. Secondly, it uses no toxic solvents. Traditional PFAS destruction methods create poisonous byproducts. This new method does not. Third, the fluorine is recovered, not destroyed. Fluorine is rare and expensive. Mining it is environmentally damaging. This method extracts fluorine from waste instead of the earth. Fourth, it prevents PFAS from leaking into the environment. Right now, Teflon ends up in landfills, and over decades it breaks into micro-PFAS that spread into water. This method stops that. Fifth, it opens the door to recycling many more PFAS materials. Not just Teflon cookware but electronics coatings, lubricants, firefighting foams, waterproofing sprays, chemical-resistant pipes, surgical equipment, non-stick industrial films. We may finally have a tool to clean up decades of forever pollution. The full step-by-step procedure, never explained before. Here is the actual mechanochemical process, simplified for understanding but scientifically accurate. Step 1. Collection and cleaning. PFAS waste is collected from old Teflon cookware, industrial coatings, waterproofing textiles, medical devices, electronics factories, firefighting foam storage tanks. The waste is shredded and washed to remove surface contaminants. Step 2. Pre-processing into microgranules. Large pieces of Teflon are ground into micro-sized particles for efficient reaction. Particle size is critical. Smaller particles is equal to more surface area is equal to faster destruction. Step 3. Mixing with reactive metal oxides. The Teflon powder is mixed with a reactive chemical, often magnesium oxide or calcium oxide. These chemicals have a purpose. They grab the fluorine atoms once they break free. If fluorine is not captured instantly, it recombines into toxic gases. Step 4. Planetary ball milling. The mixture goes into a planetary ball mill. A spinning drum filled with steel or tungsten carbide balls rotating at up to 600 rpm, producing millions of high-energy collisions. Every collision breaks molecular bonds. In hours, the once invincible Teflon polymer chains are shattered into dust. Step 5. Formation of fluoride salts. The freed fluorine reacts with magnesium oxide to form magnesium fluoride, MgF. This compound is incredibly valuable. It's used in smartphone camera lenses, telescopes and optical equipment, lithium batteries, medical drugs, anti-reflective coatings. This means PFAS waste becomes a resource. Step 6. Separation and purification. The resulting powder is washed with water. Harmless carbon fragments dissolve. The fluoride salts remain as solid crystals. They are dried, filtered, and collected. Step 7. Reuse in industry. Finally, these salts are used to manufacture medicines, solar panels, batteries, specialty glass, aerospace coatings, quantum electronics. This is the first time in history that PFAS waste is turned into valuable industrial feedstock instead of toxic trash. The hidden benefit almost no one is talking about. Here's the part the media didn't highlight. Fluorinated chemicals are essential for modern medicines. Nearly 20% of all pharmaceuticals use fluorine because it improves stability and absorption. But fluorine doesn't come from a renewable source. Industry mines a mineral called fluorspar, often in unsafe conditions, and the purification process creates toxic waste. This new method could allow drug manufacturers to get fluorine from recycled Teflon instead of mining. That means cheaper medicine, cleaner production, reduced mining pollution, and a sustainable fluorine economy. This is not just a recycling method. It's a potential revolution for global healthcare. The future of forever chemicals. So what happens next? If governments invest in this technology, we could soon have PFAS recycling plants, just like plastic bottle recycling centers. Imagine that. A world where your old non-stick pan becomes part of a cancer medicine, or a solar panel, or a next-generation battery for electric cars. A world where forever chemicals no longer last forever. A world where one of humanity's biggest pollution problems becomes one of our most valuable resources. This breakthrough is more than science. It's hope. Hope that the most indestructible materials we ever created can finally be transformed, reused, and reborn. What we once believed could never be undone has finally been broken. From toxic waste to valuable resource, the forever problem just met its solution. Thanks for watching. If you like this video, like, share and subscribe to the channel. This is Global Bytes, bringing you the hidden science shaping our future, one discovery at a time.